Okay, so today we're starting the second half of chapter 7, which has more focus on polynomials than on exponents. We will still need to use the exponential rules we learned in the first half of chapter 7, but the focus will be more on polynomials than on exponents. Cassie, would you shut the door for me? Thank you. So this section is kind of an introduction to polynomials. There's a lot of vocabulary. So a lot of this section is just getting familiar with the new vocabulary words that you will see. The first vocabulary word is monomial. A monomial is a number, a variable, or a product of numbers or variables with whole number exponents. So what does this word product mean?
It's an answer to a multiplication problem.
It's an answer to a multiplication problem. That's exactly right. So notice product is the only operation that is included. Multiplication is the only operation. So a monomial is basically numbers and variables being multiplied together. You won't see addition with monomials. You won't see subtraction. You won't see division. You will only see multiplication. So all of the examples of monomials have numbers. It can be just a number by itself, it can be a variable by itself, or it can be a number and variables being multiplied together. It can have an exponent as long as that exponent is positive. In this example of non-monomials, you'll notice we have a negative exponent, which is why this one is not a monomial. We have a subtraction sign, which is why this is not a monomial. And we have a division or negative exponent, which is why this is, again, not a monomial. The degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So first of all, what does sum mean? Yes, the answer to an addition problem. So basically you're going to add all of the exponents of the variables. Okay, one thing that is really important that you know is that a constant always has a degree of 0. Okay, even though the exponent of a constant is not 0, it still has a degree of 0. For example, the number 3 has an exponent of what? What's the exponent attached to this number? 1. Okay, 3 to the power of 1 is 3. However, if you were giving the degree of the number 3, like it's asking you to do in letter C, the degree is not 1. The degree is actually 0. Because what the degree is referring to is the exponents of the variables. Since 3 does not have a variable, that's why it has a degree of 0, because there's no variable that's attached to 3. So the degree of any constant is 0. Okay, sometimes they will try to trick you by giving you a number like 6 squared, because they want you to say that the degree is 2. Because that's what the exponent is. But in this case, the degree of 6 squared would still be 0.
Wait, why though?
Because degree and exponent are two different things. The degree of 6 squared is still 0 because the degree is talking about like it says, the sum of the exponents of the variables. Sum of the exponents of the variables. What's the variable for 6 squared? There's not one. Okay, 6 squared is the exact same thing as 36. There's no variable, so the degree would be 0. I'm not saying that 6 squared equals 0. I'm just saying the degree of 6 squared is 0. Okay, so let's look at letter A. In letter A, we do have some variables, so finding the degree is very simple. We're going to look at the variable, the exponents of the variables, and add them together. You're not adding the exponent of the whole number, just the exponent of the variables. So the exponents, the variables have exponents of 4 and 3. 4 plus 3 is what? 7. So the degree of letter A is 7.
Wait, what is a variable? P and Q?
Yes, variables are the numbers the letters that represent numbers that can change. Okay, how about B? What do y'all think the degree of letter B would be? 2. Both E and D have an exponent of 1. 1 plus 1 is 2. We already talked about letter C has a degree of 0 because it's a constant and it has no variables. What about letter D?
Since it's a number, it's on 0.
Yes.
It has to be a letter that has
Yes, it has to have a variable to have a degree. Okay, what about letter D? 3, good. 2 plus 1 is 3, degree of 3. Letter E, 1. And letter F, 3. Okay, the next vocabulary word is polynomial. A polynomial is a monomial or a sum or difference of monomials. So again, we see these words, sum and difference. What does sum mean?
Plus or
Addition. Difference?
subtraction.
Subtraction. So with polynomials, you're going to take monomials and you're going to combine them together with an addition or subtraction sign. For example, you could have 2x squared plus 3x plus 6. This is 3 monomials, 2x squared, 3x, and 6, being combined together into a polynomial by addition. You could also have 5x minus 10. This is a polynomial because we have 2 monomials combined together with subtraction.
I don't understand. Yeah, what would the answer be?
There's not an answer. I'm just showing examples of polynomials. A polynomial is a mathematical expression that has more than one term combined together with addition or subtraction. Okay, the degree of a polynomial is the degree of the term with the greatest degree. So when you're finding the degree of a polynomial, it's a little bit different than when you're finding the degree of a monomial. For example, in letter A, we have 11x to the power of 7 plus 3x to the power of 3. Now, what you'll be tempted to do is to say that the degree is 10 because 7 plus 3 is 10. But since this is a polynomial and there's more than one term, what you do is you find the degree of each individual term and then just choose the highest one. So we have 2 terms in this example, 11x to the power of 7 and 3x to the power of 3. 11x to the power of 7 has a degree of what? 7. 3x to the power of 3 has a degree of what? 3. Now it says you're going to choose the one with the greatest degree. So which one has the biggest degree?
11x.
Okay, so the degree of this entire thing is just 7. Yes?
Like quizzes and tasks, are these going to be like separate from other ones so we don't get it confused and I can?
It will just be just like this where it says find the degree of the polynomial. Okay, in letter B, we have 3 terms. 1, 2, 3. You'll notice each term is separated by an addition or subtraction sign. In the first term, negative 1/3 w squared z, what's the degree? 3. In the second term, 1/2 z to the 4th, what's the degree? In the third term, negative 5, what's the degree? 0. So the greatest degree is 4, so the degree of the entire polynomial is also 4. So Connor, what do you think the degree of letter C would be? 1. The degree of letter C is 1 because 5x has the greatest degree of 1, so the whole thing has a degree of 1. Okay, how about letter D, Cassidy?
5.
Good, 5. Letter D has a degree of 5. There's actually 2 terms that have a degree of 5, but it's still the highest degree, so the highest degree wins. The whole thing has a degree of 5.
So everything that's like sectioned out by a plus sign or a minus sign.
Yeah, so each one of these is a monomial. You can tell because they're separated by an addition or subtraction sign. So this has 1, 2, 3, 4 different monomials. And you find the degree of each separate one, and then the highest one wins. Okay, the standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to least degree. When written in standard form, the coefficient of the first term is called the leading coefficient. So we have 2 more vocabulary words here that you need to be familiar with. On the back side, you'll see the instructions say write the polynomial in standard form, and again, then give the leading coefficient. So you have to be able to know what it means by standard form and what it means to give the leading coefficient. You always have to write it in standard form first, okay? Writing a polynomial in standard form is very simple. All you're going to do is look and find the degree of each monomial or each term, then reorder those terms so that they're in order from greatest degree from least to least degree. So in letter A, we have 1, 2, 3, 4 different terms. Okay, 6x is the first term. What is the degree of 6x? 1. Negative 7x to the fifth is the second term. What's the degree of that one? 5. 4x squared has a degree of, and 9 has a degree of. Okay, so to put it in standard form, all I'm going to do is rearrange those terms so that they're in order from greatest degree to least degree. So which one should go first? Okay, 5 is the biggest degree, so negative 7x to the fifth is going to go first. Make sure you take the negative sign with it. Okay, what's the next biggest degree?
4x.
Okay, so I'm going to do plus 4x squared. And then what would be next?
6x.
Plus 6x. And last, plus 9. So this is the polynomial in standard form. The last thing I have to do is give the leading coefficient. Okay, coefficient means the number in front of the variable. So when it's in standard form, you're going to look at the first term, and the leading coefficient is simply the number in front of the first variable. So in this case, the leading coefficient is what? Negative 7. Okay, so using that information in letter B, if we're writing it in standard form, which term should go first? Y to the power of 6, good. Plus y squared minus 3y. Anyone want to try what the leading coefficient is in this problem? Say it again. 1, that's exactly right. Students are tempted to say that the leading coefficient in this case would be y because they say there is no number in front of y. But there is a number in front of y. It's the number that we don't have to write, and that's 1. You don't have to write 1y to the 6th, but any variable without a number in front of it really has a number of 1. So the leading coefficient is 1. Okay, letter C, 16 minus 4x squared plus x to the fifth plus 9x cubed. So Connor, what variable, what monomial would go first in standard form?
X to the 5th power.
Good. Keep going.
Gonna be 9x to the 9x cubed. Gonna be minus 4x to the squared.
Uh-huh.
Plus 6.
Very good. And the leading coefficient? Good. Notice you have to put it in standard form before you can identify what the leading coefficient is. Okay, Madeline, how would you write letter D in standard form?
Okay. It would be. It's already. Well, no. Minus 3, 5, 8 plus 18 plus 14
And the leading coefficient is what?
minus 3.
Negative 3. Good. Okay, one of the last things you have to do in this section is classify or name polynomials. So it says some polynomials have special names based on their degree and the number of terms they have. So you'll notice there's 2 different tables. Each polynomial is going to get 2 names, one based on the degree it has and one based on the number of terms it has. So every name that you give will have 2 parts, okay? One from this table and one from this table. On a quiz or a test, I'm not expecting you to memorize all of these words. You'll basically get a word bank. So you'll get a word bank and it just won't have the number part of this table in it. It'll have all these words and all these words, but you'll have to know that constant means 0, linear means 1, and so on.
They're just gonna mix them up.
Right. Okay, this names especially of the polynomials are kind of easy to remember because they have these root words in them. Mono means one, bi means two, and tri means three. It's important for you to understand that all of these are polynomials, okay? A monomial is also a polynomial. A binomial is also a polynomial. It's just when they have one, two, or three terms, we have more specific names that we can call them. Okay, and then once it gets to four or more, there's no more specific names, so we just call them in general a polynomial. But all of these are types of polynomials. Okay, a monomial is a type of polynomial. A binomial is a type of polynomial. They just have more specific names when they have one, two, or three terms. So when you need to classify each polynomial, what you need to do is look at two things just like the instructions say. Look at it, classify it based on its degree and the number of terms that it has. So in letter A, what would the degree be? Cubic. And how did you know that it was cubic?
Because degree is 3.
The degree is 3, and if we look right up here, 3 is called cubic. And the second thing you need to do is identify the number of terms, which in this case is
Wait,
Does it matter what order we put it in?
yeah, you want to do degree, then terms. So this would be cubic binomial because it has 3 degrees and 2 terms. Cubic binomial. Okay, how about the next one? What's the degree of this next one? You can just say the number if you don't know what the name is. Okay, it's a 6th degree. So anytime there's more than 5 degrees, we're kind of done with the special names and you just call it by the degree. So when it's 6th, you just call it 6th degree. And since it has how many terms? 1, 2, 3, 4. It would be a polynomial. So that's called a 6th degree polynomial. Negative 2x has a degree of
linear.
1, so it's linear. And how many terms does it have? 1, so it's a monomial. So that's a linear monomial. Okay, the last part of this section just is going to ask you to use polynomials to help you solve some real-world word problems. Can someone please read the first example for me?
The tourist accidentally drops her lip balm on the Golden Gate Bridge. The bridge is 220 feet from the water
It's supposed to say off.
off the bay. The height of the lip balm is given by the polynomial negative 16 t power 2 plus 220. Where t is time in seconds. How far above the water will the lip balm be after 3 seconds?
Okay, so to solve this problem, we're going to use the formula given to us, negative 16t squared plus 220, and the information given to us that it has been falling for 3 seconds to solve the question. So what do I need to do? Plug 3 in for t. So I'm going to plug in negative 16 times 3 squared plus 220. On your calculators, if you're using a graphing calculator, you can type that in and do it all in one step. A couple of important things to remember about your calculator. First of all, the negative sign is different than the subtraction sign. You have to use the negative sign next to the decimal. The second thing is, instead of using the multiplication sign, if you will use the parentheses, that will make your life a whole lot easier, especially when you're looking at negative. Now, if you're not using a graphing calculator, you're going to have to do this one step at a time. So don't try to type it in all at once unless you are using a graphing calculator. If you're not using a graphing calculator, you'll need to follow the order of operations and plug the problem in one step at a time. So you would do 3 squared, then that times negative 16, then that plus 220. So what do you get when you solve that? No?
Or solve all of it, final answer.
Uh-huh.
76.
76 is correct. Good. And the way he put the units on the answer is correct. Make sure, since it's a word problem, that you write your unit on your answer.
How do you go like back down after
Wait, how do you?
use the right
I
arrow.
actually-
If you click it, you'll go down.
Show me,
Yeah.
pass me.
So you would click the right arrow to go down after the exponent.
Oh,
because
okay.
If you type in an exponent, it stays up there until you
Right.
hit the right
Oh,
arrow.
okay, gotcha. Yeah.
Wait, can you? Oh.
I'll help you with your calculator in just a second if you need it. Okay, the next one says firework with 5-second fuse is launched from a platform at a speed of 400 feet per second. Its height is given by negative 16 t squared plus 400 t plus 6. How high will this firework be when it explodes? So what do we need to do to solve this problem?
Add 5.
Plug in 5 for t. Yes, negative 6 times 5 squared plus 400 times 5 plus 6. So again, on your calculator, make sure you're using the parentheses for multiplication. That's not what I got. 1,606 feet is what I got. So be careful with your calculators. A lot of times when we're using our calculators, we just plug it in, write down whatever it says without even a second thought of whether that or not that makes sense. If you don't plug in your problem correctly, your calculator is not going to give you the right answer. So be very careful and make sure that the answer your calculator is giving you is making sense. And you also want to double check and make sure that you typed in the problem correctly, because just because you're using a calculator doesn't 100% mean that it's been done the right way. So just be careful with that. Okay, does any